If a black hole looks perfectly black and sealed from the outside, how could it possibly leak or evaporate at all? In the energy filament theory, that dark ring is not a dead boundary but an ultra-stressed skin full of microscopic pores that are constantly opening and closing, quietly letting tension and energy seep out. Textbooks usually treat the event horizon as a clean mathematical surface, a one-way line in a diagram where light goes in and never comes out. So your intuition says nothing happens there. In this picture, the horizon is more like the surface of a soap bubble that has been blown to its absolute limit. A film so thin and tight that it shines and vibrates and looks as if one more push would pop it. Imagine that bubble is wrapped around a raging pressure cooker. Deeper inside the black hole, the piston layer is breathing, the steering core is boiling, and the shredding belt is constantly grinding and falling matter into raw energy filaments. Each surge of that internal activity slams into the underside of the outer skin like a finger jabbing the inside of the bubble. A normal soap bubble does not necessarily explode when touched. It often forms a tiny break that opens just enough to release a hint of stress, then rapidly heals. The horizon behaves the same way in this view. Under each sharp internal pulse, the skin sprouts a microscopic pore, a tiny hole that flashes into existence, lets out a sliver of tension and a thin spray of organized motion, and then snaps shut again on a timescale so short that, from far away, it still looks like a smooth black circle. You can think of each pore as a valve on a pressure cooker lid, hissing for a heartbeat and then sealing, preventing the whole system from tearing itself apart. These pores are not damaged, they are the stabilization mechanism. Without any pores at all, the outer layer would have to hold impossible stress with no way to bleed it off. Like welding the safety valves shut on a boiler and then turning the heat up forever. With pores, the black hole can live in a long-lived, almost steady state, swallowing matter from outside while quietly exhaling energy back into the surrounding sea. So what does this mean for the idea that black holes evaporate? In this picture, evaporation is not a smooth mist flowing off a static surface. It is the long-term result of countless tiny pore events. Each time a pore opens, a tiny packet of energy filaments or low-level radiation leaks out instead of staying locked in the core. A single hiss is almost nothing. Trillions upon trillions of hisses over cosmic time add up to real mass and tension lost. The character of those hisses depends strongly on the size of the black hole. A very massive hole has a huge surface and enormous total tension, but each pore is relatively gentle, like a deep sea bubble that rises slowly and steadily from the ocean floor. Seen from outside, it evaporates incredibly slowly, changing only over unimaginably long times. A small black hole, by contrast, has less area and far more extreme curvature of the energy sea near its skin. The same need to vent is squeezed through a much tighter membrane, so pores open and shut more violently and more often, more like popcorn kernels rattling in a hot pan. Its evaporation is frantic and rapid compared to that of a giant. From far away, we still only see a dark patch and some radiation. Up close, this view says the horizon is actually the busiest part of the whole machine. The thin layer where deep internal turmoil is translated into tiny leaks that keep the structure stable. The punchline is that a black hole can be both black and slowly evaporating at the same time, because the surface that looks perfectly sealed at our distance is actually a living membrane full of short-lived pores, constantly breathing out just enough to survive its own internal pressure. In the next episode, we will dive down one layer to the piston zone and ask how that hidden muscle gives black holes their moods, rhythms, and spectacular outbursts. Tap follow, share it on New Physics, Clear Universe.